this video, we will start with parametric differentiation. You will find this on page 501 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Parametric differentiation. There are also curves that we can't even write down as a single equation in terms of only x and y. So to deal with some of these problems, we introduce parametric equations. Instead of defining y in terms of x or x in terms of y, we define both x and y in terms of a third variable, for example, t. Okay, so this is an example. X equals cos t and y equals sin t. This variable t is then called a parameter. We can find the curve given by the parametric equations x equals cos t and y equals sin t for t bigger than equal 0, smaller than equal to 2 pi by finding the values of x and y for particular values of t. So if we substitute that 0 therein, this is the values that we will get for x and for y, and the same there. Then, by plotting the points given by the x and the y coordinates in the table and joining them with a smooth curve, we obtain the following graph. Okay, there is the graph. Now, just note, in practice, you might need to plot several more points before you can be confident of the shape of the curve. Okay, now this was a circle, so it was not so difficult. So when a curve is given in parametric forms in terms of a parameter t, we can use the chain rule to find dy over dx. Okay, so first we differentiate y to t, so dy over dt, and we get cos t. Then dx over dt, we get negative sin t. But now we want to go to the chain rule, and now this is very important that you notice this. We want to get dy over dx. So basically, this one with the x must be turned around. So we swap this side around and then we swap that side also around. The reason why is that we can get dy over dx because as soon as it's swapped around, this will cancel out and we end up with dy over dx. So it's basically this one, multiply this one, and if we just bring it up, we get cos t over sin t, and that's equal to negative cot t. Okay, and that is the basics. But let's look at an example. Just going to make it a bit bigger. It's not very, very difficult if you first just understand the process. Okay, let's start. A curve has parametric equation x, y, and it's both in terms of t. So find the expression for dy over dx. I basically differentiate it in terms of t. So first differentiate the first one, then differentiate the second one. Now remember what I said. Make sure it's not always that the one, that dx, you want the dx at the bottom. So that one you turned around. So you turn that side around and you turn this side around. And then if you multiply, the t's will cancel and you end up with dy over dx. And then you basically just put this over 1, okay, and simplify and get an expression. Okay, so I want you to stop the video and I want you to do number A. Again, you can continue the video as soon as you are finished. Okay, let's start. The first one, number A. Okay, I have x is equal to t squared. And y is equal to 2 minus 5t squared. Okay, so I have dx over dt. Always first do that. And then I differentiate to t, so it's 2t. Then I have dy over dx. And if I this is a constant, becomes 0. This is negative 10t. Now make sure which one you must swap around. You want dy over dx. Oh, sorry, luckily I saw that. Can I just correct it? And sometimes I leave the mistakes so that I can correct it because you're going to make some of the same mistakes. Remember, dy on top, dt at the bottom. That's very important. Okay, now the one that I want to swap is this one, because I want the x at the bottom. So therefore, dt over dx, so this one is 1 over 2t. Okay, and now you can start with the statement. dy over dx, can I just show you? So you're going to say dy over, that's the chain rule, and you multiply with the dt over dx. Okay, the reason then this cancel out. Okay, so let's start there, dy, so negative 10t over 1 multiply 1 over 2t. The t's cancel and the answer is negative 5. So you